Greetings students, welcome to Survey 1A, chapter for Tacheometry. Um, as shown here are the equations that you'll actually use when you're busy doing tacheometry calculations. As you can see, you have your equation for reduced bearing here, which is observation plus your adjustment. And you have your reduced slope angle, which is actually always 90 minus the vertical observation. You have your HD. You know that when you have to calculate your HD, you need your slope distance, which is your SD, and your slope angle. As you can see, those are the equation there. And then you also have your VD, which is this equation. You have your dy, which is actually your change in y. You know that you need your HD and your bearing. And for your dx, which is your change in x, you need your HD and your bearing again. As you can see, those are the equations. And you will always be given this when you're busy doing your calculations. As you can see, you have your horizontal observation, your vertical observation, your slope distance, your reference observation, and then you have your instrument height and you have your target height. As you can see, I also showed the abbreviations so that you can be well aware when you see them on your table. I would love to show you some theory behind determining the elevations on tacheometry. These are actually some diagrams that I actually wanted to show you, because you know that in tacheometry you're actually determining coordinates and elevations. So in this case, you remember when you were doing your traverse, you would also find that you would actually determine your coordinates. But then you were supposed to, in traverse, you find that you had to remove your station from one point to another. But then in this case, for tacheometry, your station remains in one point and you take readings in various areas to determine elevation on your coordinates. So, and of course, you'll be using the same instrument. You'll be using the same instrument to determine such. And then here, as you can see, you have a diagram that actually shows your station that is actually below. As you can see, this is actually your station, which is at elevation at A, and that means you would have to know your elevation at your station, and you're actually determining your elevation at B. And as you can see, your station is below. This is actually a simplified diagram. In order for you to determine the elevation at B, that means you'll actually need to have your instrument height, which is IH, your target height, which is TH, your vertical distance, which is VD, and then you also need your elevation, of course, of the station, which you always know, to determine the elevation at the other point. So as you can see for this diagram, so that you can understand how you actually determine your elevations. My mistake, this is actually VD, not VB. My mistake there. So that means in order for you to determine the elevation at B, you need to know the elevation at A. So it's going to be the elevation at A plus your target height plus your, oh, my mistake. It's actually your elevation at A plus your instrument height. As you can see, this is the instrument height. This is actually your target height. So you always subtract your target height. You always subtract your target height. Don't forget that. And as you can see, the elevation at B, which you're actually trying to determine, is actually above. And you can see, as I said, this is actually your VD. So that means you actually add your VD because you're actually moving upwards. You're actually taking a reading upwards. So you add your VD in this case. But then if your station is actually above, as shown in this diagram, you can see that right now your station is actually above and you are actually determining the elevation below. You can see your VD is this one, and you have your instrument height, you have your target height, which is actually below. So in this case, to determine, it will be the elevation at A, which is actually known, which is your station, which is now above, plus your instrument height. As I said, you always subtract your target height, which is this one, minus your target height. And then because VD, you can see you're moving below on your target. That means you subtract VD. Usually, even when you look at your table, you'll see when we are busy doing our calculations, if you find the negative VD, that actually tells you, even before, if someone was to give you such data, you know that if you see a negative VD, you know very well that that means your target is actually below. So in this case, you can see the VD is actually negative. So that means you actually add it and you don't omit the sign of the VD. You take it as a negative. That will obviously mean that you have to subtract your VD. So I'll actually stop here with the first part of actually explaining, but then let me just further show you the equation, because I didn't show you the equation of determining your adjustment. Your adjustment is actually shown here. Your adjustment will actually be your joint bearing, as you can see, minus your reference observation. Your reference observation is always given. You remember, that's what I told you. But then your joint bearing, you'll have to determine, because you'll be given 2 points. You remember, you can calculate your joint bearing, which is also your reduced bearing. You can actually determine it from 2 known points. So you'll always be given 2 known points, which you can actually determine your joint bearing. And then you can subtract your reference observation, which is also given to determine your adjustment. So that is actually the equation there. And then from there, in order for you to actually determine the other reduced bearing on your table, I'll actually show you when we go further. You'll actually have to use the adjustment that you determine from those 2 points and add it to the observation, which is actually the horizontal observation, to get all those other reduced bearing. So I'll actually stop here for now, and then we'll go on with our calculation. Thank you.